This question is asking investigate whether as an alternative to cascoding we can simplify increase the channel length L of the CS MOSFET. Specifically, we wish to compare the two circuits shown in figure P8.70B and C. The circuit in figure P8.70B is CS amplifier, which is the channel length has been quadrupled relative to that of the original CS amplifier in figure P8.70A, while the drain current bias has been kept constant. Okay, here we have a picture A, B and C, and the A part of the question is asking show that for this circuit V over drive is double that of original circuit, GM is half that of the original circuit, and V over Vi is double of the original circuit. Okay, now let's go ahead and see how we can solve that. So here we are comparing the A and the B, and in that one, first we are going to see what is the relation between the V over drive. So if you notice, the current are equal for both of them. The only difference I am seeing here is this is W over 4L and this one is W over L. And if you look at the current equation is given by this is a PMOS. You can see the arrow is pointing outward. So I is equal to half times mu n COX W over L times V over drive square. And we can also say this one as half time, instead of mu n COX you can write like Kn W over L V over drive square. And if I take it for the first one, for figure A, we can say I is equal to half times Kn with over length W over L, and V over drive we can say V over drive 1 square. And for figure B, we can say I is equal to half Kn. In this case, this is W over 4L and V over drive 2 square. And the current are equal. You see both of them has I current, so we can say if we say 1 and this one is 2, since I is equal, same, equation number 1 is equal to equation number 2, we can say half Kn W over L V over drive 1 square is equal to half Kn W over 4L V over drive 2 square. And here we can cancel the like terms, like half Kn cancel, W over L cancel. Finally we will end up getting, let me bring it to next page. So what is left here is V over drive 1 square is left, and in the other side of the equation we have 1 over 4 left, and then time V over drive 2 square is left. 1 over 4 V over drive 2 whole square. And if you rearrange this one, this is going to be V over drive 2 square over V over drive 1 square is equal to 4. Therefore, if you square root both sides, this is going to be V over drive 2 over V over drive 1 is equal to 2. Therefore, we can say V over drive 2 is equal to 2 V over 1. This is one of the proof that asked us to find out. We had to show that V over drive 1 is double of V over drive 2. I mean, V over drive 2 is double of V over drive 1. Here, show that for the circuit, V over drive is double that of the original circuit. And the next part, we had saw that GM is half of the value of the original circuit. Okay, so let's do for the GM right now. Now, GM is nothing but 2 times id current divided by v over drive. Okay, and id current in our case is I, 2i over v over drive. I is same for both of them, so the only thing that's going to be differ is v over drive. And if you look at the relation between the transconductor and v over drive is transconductance is directly proportional to 1 over v over drive. So we can say gm, if you compare gm1 and gm2, gm1 over gm2, gm1 will be sorry, gm1 will be directly proportional to 1 over v over drive 1, and gm2 will be directly proportional to 1 over v over drive 2. Since that is in the denominator, the v over drive 2 flip and go to the top, and v over drive 1 will be on the bottom. And from the first one, we found out the relation between v over drive 2 and v over drive 1. v over drive 2 is nothing but 2 times v over drive 1. So instead of this v over drive 2, we can replace that one with 2 v over 1 right here, v over 1 divided by v over 1. And that so here v over 1 we have a cancel, we get 2. Okay, and we want to see what is the we want to see the gm is half of that original circuit, so we want to see the relation of that new circuit. We want to express in terms of the new, we want to express in terms of gm2. So if you rearrange this one and write in terms of gm2, gm2 is going to be equal to 1 over 2 gm1. So you can see it's half of the original one. Okay, and the next one is asking, and VO over drive VI is double of the original circuit. V output voltage over input voltage is nothing but it's a gain. And if you look at the equation for the gain is given by A naught, that is equal to GM times the output resistance. And GM is nothing but 2 times ID divided by V over drive. And the output resistance is nothing but early voltage times the times the length divided by the current, ID current. Here what we can do is we can simplify this equation. ID cancels and others remain the same, so 2 VA prime L over V over drive, and for both of them the VA prime is same, 2 is just a constant, so we don't have to worry about these two terms, and we have to just see what is this length and V over drive proportional to this gain. Length is directly proportional, 1 over V over drive also directly proportional, so we can say A naught is directly proportional to L over V over drive. Because these two terms are same for both of them, only these two terms going to be differ, so that's why we are seeing what's the relation between this one and the gain. Now we want to see for both of them, so we can say if we find the ratio of gain of the first one and the gain of the second one, that will be equal to gain of the first one, we can say L1 over V over drive 1, and the gain of the second one, that's in the denominator, so that's going to be flipped. So whatever the value on top will be here, L2, and whatever value in the bottom will be on the top, V over drive 2. And L1 we keep it as it is, and then V over drive 2, if you really find the relation between, we are trying to bring all into trying to bring in like terms so we can cancel something. Okay, so here V over drive 2 is equal to 2 V over V1, so instead of V over drive 2 we can write 2 V over V1 right here, and instead of V over V1 we keep it as it is. And then L2, if you look at the diagram, the length of the first one and the second one is 4 times larger. The length is 4 times larger, so we can say 4L. 4L1 here. Okay, so from this one we can just cancel all the like terms. V over drive 1, V over drive cancel, L1 cancel. Finally we end up getting 2 over 4. That is A01 over A02. Therefore we are trying to find the gain in terms of second one. So A02 will be equal to, and this one is nothing but 1 over 2. You can register it 1 over 2 here. So A02 will be equal to 2A over 1. Okay, and that is doubled. The second one, the gain of the second one is double of the first one. So here that's what they're asking us to prove. And V over Vi is double of the original circuit. That's what we prove right here. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.